section 6.9. This is a section on probability. Okay, probability literally means a percentage where you have success over total. So let's say somebody was going to come to your house and pick somebody to go eat pizza. If you have 8 people in your household, the only person that you would consider successful for them to pick would be you. So your probability is a 1/8 probability, but I have to turn around and make that into a percent. Remember, I can make it into a percent by doing this. So I'm going to cross product, so I have 8x is equal to 100. And when I divide, I'm going to get, let's see, 12.5%. That's going to be my probability of being chosen to go eat pizza. So you always want to have total on the bottom and what you would consider successful on the top. So if I have these poker chips, and I grab a handful of poker chips, and I say, well, I want to know what the probability of choosing a blue poker chip out of all of these are. So I have to sit here and I have to figure out how many I have and what colors I have of each. So I actually have 5 white. I have 6 red. And I have 1 blue. So when I add that all up, I have 12 poker chips. So the probability of getting a blue, I'm going to put the 12 on the bottom and the 1 on the top. So it's going to be 1/12, but that's a fraction. If they ask me for the percent, I have to turn around and make a percent out of it. So I have 12x is equal to 100, and when I divide that, it's going to be, let's see, 12 into 100. It's going to go 8 times. Do a decimal. It's going to go 3 times. And I'm going to find that it repeats right there. And if they want me to round it to the nearest 0.1%, then I go one more time, and then I'm going to round to that spot. So it's 8.3%. But if I wanted to know what the probability of getting, I don't know, a blue, a not blue, let's say a white. Probability of getting a white. Well, I have 5 white out of a total of 12. So there's my fraction, it's 5/12. But if they ask me for a percent, I've got to change that into a percent. So I have 12x is equal to 500, and I'm going to divide. 12 into 500 goes 4 times. Bring down a 2, goes 1 time. Got to keep going till I go 2 places after the decimal so I can round back. So that's going to give me 6 times, which would be 72. And it's going to repeat like that. So it's going to be 41.7%. So they might ask for that, and they might ask you for that. It just depends on the problem. If you look in your book on page 311, on example number 2, it says, suppose 2 number cubes are rolled. Find the probability of rolling an even sum. So what they did, if you look at that example, they gave you all the possible combinations you could do. If you do a 1 on the first dice, then you could do a 1 on the second, a 2 on the second, a 3 on the second, a 4 on the second, a 5 on the second, or a 6 on the second. So basically what you have is the dark green is what you have on the dice. And then the combination numbers are what you get when you roll it. So if you look there, you've got 36 total possibilities. And they asked you for an even sum. So you find out which ones give you an even sum. Like 1 plus 1 is 1, 1 plus 3 is 4, and so forth. And if you work your way through that chart, you'll find out that there's 18 of them. That reduces down to 1/2. So if they're asking you for a fraction, you've already done it. But if they're asking you for a percent, you have 1/2 is equal to x over 100. So you have 2x is equal to 100, or x is equal to 50. You have a 50% chance of rolling a sum that is even. You do have two different things. You have something that's called experimental probability and theoretical probability. Okay, what we've been working on is theoretical. We don't actually know what would happen, we're just basing it on what we think. So, if I said, what is the probability of you rolling this dice and getting a 2? The theoretical probability would be 1/6. Okay, one success out of a total of 6 different numbers. Experimental would say, let me experiment, roll it 6 times, and see how many times I get, I don't even remember what we were trying to get. Let's say we're trying to get a 5, okay? So I have a 1/6 theoretical probability of getting a 5. Now that does not mean that if I roll it 6 times, I'm going to get it 1 out of 6. But let's see. Okay, there's a 1. I rolled a 1. I rolled another 1. I rolled a 3. I rolled a 4. I rolled a 5, okay, which that's good. I rolled a 5, so that's success. Let me see what I get. And I rolled a 2. Okay, so that actually is a total of 6 times. So I actually, my experimental, I got 1 out of 6. But there's no guarantee that you're going to. It is just a prediction of what might happen when you roll it, what your chances are when you roll it. They have, in your homework, they have a section that has spinners on it, and really the total key behind this section is understanding that probability is success over total. If I wanted to know what my probability of flipping heads when I flip a coin, okay, I can have 2 possibilities. I can get heads or I can get tails. So there's a total of 2 on the bottom, and only one side will be considered successful. So I have a probability of 1/2 of getting heads, which is the same as 50%. All right, your homework on this section is page 313, 12 through 34. Make sure you read the instructions.